Well, we thank you guys for joining us here for our May webinar, and excited to have both Andrew Weaver from NC State and Etienne Richards there from New York, talking about RAM selection and also talking about some of the tools that maybe we have access to now, or can maybe use as commercial producers, as seed stock producers, to make better RAM selection. So Andrew's going to start off the evening with discussing EBVs and a little bit of backstory, history on those EBVs, how they're calculated, and this will be recorded, accessible on YouTube through the EAPK, Eastern Alliance for Production Katahdin's website. And kind of the purpose of this topic, as we're heading into RAM buying season, or our sales season, what do we need to be looking at? How do we make those selections? And maybe we find a RAM with EBVs that can really improve our flock. So with that, Andrew, if you want to take it away, we're going to go ahead and get started.
Sounds good. Can you hear me all right?
Yep, we've got you loud and clear.
Perfect. Well, thanks for having me. Like Cam said, I'm going to give kind of an overview, maybe like a 10,000 foot view, you could say, of EBVs, and then jump into some of the probably more common traits that we think of, especially as Katahdin breeders. Certainly, there's more EBVs than just what I'll discuss this evening. There's certainly, some traits more terminally oriented that I'm not going to cover this evening. Happy to answer questions on those, though, if you are interested in those. But we'll focus on some of the growth, parasite resistance, and maternal traits that those of us as Katahdin breeders tend to focus on. And so estimated breeding values, for those that are not familiar with them, and I assume many on here are probably familiar with EBVs, but some may not be. So I thought I'd give a quick overview of what they are and why we use them. These EBVs, estimated breeding values, are simply predictors of genetic merit. So they're a numerical representation of genotype. And so you might think of, I often use coat color as an example. We think about black cattle versus red cattle, and that red is recessive. And so for a trait like that, that's relatively simple, one gene really controls that phenotype, and what we observe, it's relatively simple, right? We just use some letters. Maybe we use a capital B to represent the dominant black versus the lowercase b to represent the recessive red. You have two recessive, two little b's, and you get a red heifer, and you have one of those dominant alleles there, or it just only takes one dominant allele for them to be black. And so for traits like that, those qualitative traits, we call them, it's relatively simple to use a lettering system to denote what the genotype is and what the resulting phenotype will be. However, you start thinking about these more production-oriented traits, traits like growth rate, like parasite resistance, prolificacy. These are traits that are controlled by many, many, many genes. They're quantitative traits. And so it becomes much more challenging to express those in terms of a lettering system. We might be able to put together a lettering sequence, but it would be, pages long, and no one of us could decipher that and look at that and visually say, well, oh yeah, they're going to have 10% more lambs. We just can't tell. And so instead, we use quantitative methods, statistical methods, to be able to take into account the additive effects of each one of those genes and its effect on the final phenotype that is observed. And so we take all that into account, and the genotype that is expressed in a breeding value is really that number is the genotype. That you can think about that number that's expressed, that EBV that's expressed in a very similar way to you think about a lettering system that's utilized to denote coat color, scrapie resistance, and things like that. And so it's really at its most simplest form, just a numerical representation of genotype. And because it's a representation of genotype, and that genotype is independent of environmental factors, it is a more accurate selection tool than raw performance data, adjusted performance data, and a RAM test. RAM tests, I'm a big supporter of RAM tests. and have been involved and assisted with one for a number of years now. I think they have their place, but we also need to know, I really think the value that they provide and the service they provide is allowing breeders in an SIP utilizing breeding values to take those individuals that have been selected for superior genetic merit and test those animals up against one another in a controlled environment. And so we need to understand, you know, kind of the pros and cons, where and how to use these different selection tools that we have available to us. But know that ultimately the breeding values are the most powerful tool and the best tool we have in our selection toolbox. Now we need to recognize, though, that they are estimated breeding values. These are not true breeding values. And so that difference between the estimated and the true breeding value is represented in an associated accuracy value with our breeding values. The more we know about a trait, the better we can predict an animal's genetic merit for that trait. And so the accuracy is going to go up. And that estimated breeding value will be that much closer to the true breeding value. For a trait that we know very little about, that we have very little data, maybe it's a reproductive trait in a very young animal, no genotype information, no, we haven't sent in any TSU for genotyping or anything like that. That animal hasn't had any progeny itself. We have some pedigree information, and that's about it. The estimated breeding value is still going to be the most powerful tool we have. That estimated breeding value, even on a young animal, is still more accurate than raw performance data. But there will be a relatively low accuracy value because there's just not as much information contributing to the prediction of that breeding value in comparison to, say, an 8 or 9-year-old ewe that's had, you know, multiple litters and lots of reproductive data, prolificacy data going into the evaluation to predict a trait, one of those reproductive related traits. And so just keep that in mind, but still know that, you know, regardless, these estimated breeding values are the most powerful tool that we have. So kind of a quick 10,000-foot overview of how we get to these estimated breeding values. And I'm going to keep this, you know, as simple as possible. We're not going to get, you know, too deep in the weeds here on EBV calculations. But ultimately, when we think about, you know, the phenotypes that we observed and how an animal performs, what they look like, and things like that, that is a result of that animal's genetics and the environment that they're exposed to. Now, the majority of that phenotype comes from the environment. For most traits in general, you know, 75 to 80% of what we observe in a phenotype is going to be a result of environmental factors, and maybe only 20 to 25% is going to be genetic, and that varies by trait. And so our reproductive traits tend to be relatively lowly heritable, have relatively low genetic component, where things like carcass traits tend to be relatively highly heritable. And I say highly heritable, but still only about 30 to 35% is controlled by genetics. The rest would be environmental. We know that environment changes year to year. Environment changes from my farm to your farm. And so if we're not careful, and if all we select for is a phenotype, that animal that maybe looked great, performed great on your farm, I bring it to my farm, the environment all of a sudden changed. That animal, you know, may not be the same animal that it was on your farm. However, genotypes, genetics stay the same, right? The DNA sequence of that animal on your farm is going to be the same as when I, you know, put it on a trailer, haul it to my farm. The DNA sequence is still the same, and that genetic information can be passed on to an individual's offspring. And so we can pass on that genetic information. We can have some consistency from farm to farm. And so if I'm able to isolate genetics from environmental factors and select and make breeding decisions based on genotype alone, I can make a lot more genetic progress, a lot more improvement than selecting on a phenotype that is you know, oftentimes and greatly influenced by environmental factors that are not consistent. And so we really need to focus on genotype independent of environment. So how do we get to that point? It all starts with contemporary groups. In contemporary groups, we could have a whole lecture, spend a whole you know, an hour or more probably talking about contemporary group structure and how do we have good contemporary groups. But ultimately, a contemporary group is just a group of animals that are provided with the same opportunity, the same environment to perform in. All environmental factors, as many as we can control, are held the same. They're held constant. These animals are managed together. We feed them the same thing. They're of similar age, similar sex. They're, from a health standpoint, we manage them the same. These animals in as many ways as we can control are provided with the same opportunity to express their genetic potential. And then we see and we know that all those animals will not perform exactly the same. So then we can differentiate which ones perform better and which ones perform worse. And those differences in how an individual performs relative to their contemporary group, we would predict are largely a contribution of genetic differences, right? And so if I just focus in on an individual and compare that individual to everybody else, if that individual performed better than everybody else, had the same feed, had the same health status, same vaccination program, if that animal performed better, it's probably because they have better genetics. If an animal performs worse, well, they probably performed worse. You know, the feed was all there, the vaccination program was there, everything else was there. Why didn't they perform as well? Well, maybe the genetic potential wasn't there. And so how an individual performs relative to their contemporary group can be described with the term a selection differential. The selection differential is simply the difference between an individual and the average of the contemporary group that they're in. That selection differential may be positive, it may be negative. And so then that's the first step. So we're simply comparing an individual to their contemporaries. And then we're going to incorporate in and bring in that heritability word. And I've already mentioned that one. And heritability is simply the genetic variation relative to the phenotypic variation. So how much of the phenotype, how much of the variation in phenotype, how much of the variation in how an animal performs, how they look, what we observe, how much of that variation can be attributed to the genetic differences for that trait. And so the heritability is going to vary by trait. Like I mentioned, reproductive traits, relatively lowly heritable, maybe only 10 or 15% of what we observe in a phenotype as a result of genetics, where, you know, traits like our carcass traits, or I know this is a Katahdin group, but our wool traits are actually some of our most highly heritable traits. You know, those traits can be, you know, in the 40, some wool traits are even, you know, close to 50 or just over 50% on heritability. And so, you know, about half of what we observe in a phenotype as a result of genetic differences. So take into account the heritability. And so we take those two things together and we can predict a basic in-flock breeding value. We take the selection differential, we multiply the heritability, and we get our basic in-flock breeding value. This is where we started back in the 90s, before we had a crossbreed or a cross flock, I should say, a cross flock EBVs. We just had in-flock EBVs. And so all we had was a prediction of genetic merit within a flock. It was only relevant within a contemporary group. And then through linkages and best linear unbiased prediction technology and those statistical analysis, we were able to start comparing animals between flocks. And so now an EBV in our flock here at NC State, we can take that EBV and we can use that EBV to compare an animal in our flock to an animal in a flock in Washington State if we wanted to, because we have that across flock capability now with our genetic prediction. And so if we want to get in the weeds just a little bit here, remember I said heritability is simply the genetic variation relative to the phenotypic variation. And so if you think about, do a little bit of math here, if you insert substitute that in for the heritability component, you know, selection differential is the phenotypic measure. Really, it's just, it's how an animal performs relative to its contemporaries. So that's going to cancel out with the phenotypic measurement and in the denominator, and we're left with a prediction of genetic difference between an individual and its contemporaries. So what does this look like from a real practical sense? Let's just run through a quick example. It's like a trait like weaning weight. Let's just say an individual, their weaning weight's 50 pounds. Their the average of the contemporary group is 45. Well, 50 minus 45 is 5 pounds. So the selection differential is 5 pounds. The heritability for weaning weight is about 20% or 0.2. And so we take 5 times 0.2 and we end up with 1 pound. So the in-flock breeding value for this individual in this example would be 1 pound. And so we know that we've advanced past just the basic breeding value. And how have we done that, and what now contributes to that across flock breeding value that we're able to utilize today through NSIP. And so we have that estimated breeding value, and there's lots of things that contribute to that. It really starts with relative performance. So the genetics of the sire, the dam, all individuals in the known pedigree. We take that into account. We add in how an individual performs. Do they perform better or worse relative to what we predicted based on their pedigree information? sibling performance. So what about full sibs, half sibs? If I use a ram in our flock and then we take that ram and we use them in a different flock, there's going to be half siblings born in two different flocks, two different contemporary groups, two different environments. And now that's going to create a linkage between those flocks that allows for genetic comparisons between individuals in those flocks and a better prediction of those estimated breeding values. Progeny performance, when that animal actually gets to maturity and begins producing offspring, we can take into account how those offspring perform. Did they perform better or worse than what we predicted that individual based on their own performance? Progeny performance becomes very valuable in the prediction of estimated breeding values. Genetic correlations between traits. We know that weaning weights are associated with post-weaning weights. We know that weaning fecal egg counts are associated with post-weaning fecal egg counts. And so when we're measuring multiple traits, we can do a better job of predicting other traits that we know are genetically related, genetically correlated, that share genes. And so that goes into the evaluation. And then in the Katahdin world, we now have genomic technology. So we're actually using genomics and those SNPs, those genetic markers, to be able to better predict those estimated breeding values. And that provides a lot of value, especially in lowly heritable traits like our reproductive traits. And so all that said, we have a lot of information that contributes to one genotype, one value, one estimated breeding value that we get to utilize to make our selection decisions. And that's why these breeding values are so powerful and provide so much information and are such a useful tool for making genetic progress. So let's dive in here real quick to some of the traits we have available. What do they mean? Weaning weight. The weaning weight EBV is simply a predictor of genetic potential for weight differences at 60 days of age or about 60 days of age. It is reported in kilograms. So for those of you that maybe aren't as familiar with NSIP, we work with Lamplan Sheep Genetics out of Australia. And because we're working with a company out of Australia, all of the weight data is reported back to us in kilograms. And so relative differences doesn't really make a difference, right? Because, an animal that's got larger, higher, growth potential, growth EBVs, whether it's in kilograms or pounds, it still has greater growth potential. But if we want to get real technical and think about the exact differences and start predicting levels of performance, we do need to take that into account. This is adjusted when the evaluation calculates and starts comparing these animals. We start looking at animal performance within a contemporary group. It is adjusted for lamb and dam age, number of lambs born, and number of lambs weaned. Post-weaning weight EBV is an indicator of weight differences at about 120 days of age. And that's also reported in kilograms, and similar adjustments are made to take into account, was it out of a yearling ewe or an 8-year-old ewe or a 4-year-old ewe? And what was that litter size and what contribution or impact did that have on potential weight differences? Maternal weaning weight is a little bit of a tricky one. And, these are our meat sheep, right? And so we're not out there milking them every day. And so to help us predict or give us an indicator of potential differences in milk production, we use a trait called maternal weaning weight. And it's essentially the dam's contribution, their genetic contribution to weaning weight. So we look at, predicted differences in weaning weight based on an individual's pedigree information, and then say, did that animal grow faster than expected or slower than expected? And we can attribute some of that difference there to what the dam provided. Did she milk more? Did she milk less? And so that maternal weaning weight can be derived from that. It's also expressed as in kilograms. It's a weight trait. And this is expressed in our females, right? And so we have maternal weaning weight EBVs on our rams. And we can really use that as a predictor of, what potential milk production in that ram's daughters. But the trait itself is actually expressed in the females. And so let's just compare, and we're going to walk through a few examples of comparing a ram that's at the 90th percentile, so the top 10% of the breed for that particular trait, relative to one at the 50th percentile or breed average. And so if we look at the weaning weight EBV, a ram that would be in the 90th percentile for weaning weight EBV in the Katahdins would be 2.88 kilograms. Their EBV would be 2.88, compared to a ram at the 50th percentile that would be 1.8 kilograms. That's their own individual genetic merit for weaning weight, or weight at about 60 days of age. We know that an individual only passes on about half of their genetic merit. And so an EPD, an expected progeny difference, is simply half of an estimated breeding value. So if we take the estimated breeding value, divide it by 2, we're going to get the expected progeny difference, or what genetic potential they would pass on, what we expect them to pass on to their offspring. And so if we divide each one of these by 2, the ram on the top would hypothetically give 1.44 kilograms. The ram on the bottom would give 0.9 kilograms. So then we can compare these two individuals. It's really important to remember that an EBV does not tell us a specific level of performance. An EBV of 2.88 does not tell us that all of our lambs will weigh 50 pounds. That's simply not true. We use our EBVs. Our EBVs should be used to compare individuals. They show us relative differences in expected performance. They do not tell us exactly how an animal will perform. And so if we then compare these two numbers, take the difference between these two numbers, we would expect the progeny weight difference at 60 days of age to be approximately 0.54 kilograms. If we want to convert that to pounds, it would be 1.2 pounds. So based on the genetic merit of these two individuals, what we'd expect them to pass on to their offspring, if they were bred to the same group of ewes, so the ewes that are that dam side, the dam certainly contributing, obviously, to genetic merit of the offspring. But let's just say we're considering these two rams, we have the same group of ewes. So the ewes are not a factor. They're going to contribute the same regardless of which ram they're bred to. The ewes held constant. Potential differences in progeny weight. If we were to select and utilize the ram on the top, we would expect those offspring at 60 days of age to weigh about 1.2 pounds more per head. And so if we want to extrapolate that out to potential market value differences, I just gave a range from $2 a pound to $3.50 a pound. And so $2 a pound, we're looking at lambs that are worth $2.40 more. At $3.50 a pound, they're worth over $4 per head more, simply because we elected to use a ram that was in a greater percentile, had greater genetic merit for weaning weight, for growth in that pre-weaning period. And so another example here that we can hopefully this helps kind of illustrate how these EBVs can be used to compare individuals and think about their impact in different flocks. So we have Ram A here and Ram B, similar to the last slide I showed. And those weaning weight EBVs are listed here. Ram A, 2.88 kilograms, Ram B, 1.8 kilograms. The difference there between those rams would be 1.08 kilograms. Now, if we want to convert that to an EPD, an expected progeny difference, what they're going to pass on to their offspring, similar math to what I just did on the last slide. We divide by 2, 1.44 and 0.90, which would lead to a difference of 0.54. Now, my brain thinks in pounds, and so I tend to convert things to pounds to do these comparisons just because that's how my mind works. So if we convert that weaning weight EPD to pounds, we simply multiply by 2.2. So we're dividing by 2 to get to the EPD, and then we multiply by 2.2 to get it into pounds. And so we're now looking at the Ram A. The expected progeny difference there for Ram A would be 3.2 pounds. Ram B would be 2 pounds, with a difference of 1.2 pounds. And so let's think about how would those individuals, or if we were to use those two individuals, those two rams in two different flocks, what are potential expected levels of performance and how might those vary between two flocks? So we have hypothetical flock A and flock B. These are two different flocks, two different environments, two different contemporary groups. We breed these two rams in each one of these flocks. We develop those lambs, we get them weaned, we take some weaning weights, and we start comparing those weaning weights. In flock A, the weaning weights of the progeny of Ram A they average 56 pounds. The progeny of Ram B average 54.8 pounds. Notice the difference there being 1.2 pounds, just like we predicted based on the EPD. In flock B, Ram A, his offspring, average weight was 54.8 pounds. Ram B, his offspring, average weight was 53.6 pounds. Now notice the weaning weights are not the same. The weaning weights between flock A and flock B differ, but the relative difference in animal performance, the progeny of Ram A relative to the progeny of Ram B, the relative difference is the same across flocks. So, maybe in this scenario, flock A, maybe their nutrition program is just a little bit better. Maybe they just feed a little bit more. because of that extra supplementation, that extra nutrition, those lambs grow a little bit faster. Average weaning weights are a little bit heavier. Maybe flock B doesn't feed quite as much. Average weaning weights are a little bit lower. That's okay. The relative differences are going to be the same. And so that's really the power that EBVs provide. They're across flock. We can use them. We can make purchasing decisions, selection decisions, and bring in animals, and with that known genetic merit, and we can compare animals, and we know what that expected difference is going to be, regardless of what the averages are in my flock versus your flock. So that's just an EBV example, using weaning weight. Those growth traits, relatively simple from that standpoint to think about and illustrate examples with. The next trait is probably one of the most interesting traits to me. I'm biased. Worked with this one a lot, and I think it provides a ton of value. And it's one that certainly the Katahdins have kind of led the way in terms of implementing and showing significant progress in improving parasite resistance, reducing fecal egg counts in our population. And so we have the fecal egg count EBV. This is a trait it's a disease-related trait, right? And it's a trait that we in the sheep industry have available to us that is one of the first, or maybe we think about what we have compared to the cattle industry. Cattle industry has a lot more traits available to them, but they don't have a trait like this. And so we might be one step ahead in this regard. This trait allows us to predict differences or show differences in genetic merit related to fecal egg count, changes in fecal egg count that are directly associated with parasite resistance or susceptibility. It is reported as a percent change where negative values, lower values are better. We want to reduce fecal egg count. We want to lower fecal egg count. By lowering fecal egg count, we are going to improve parasite resistance. We have a weaning fecal egg count that's more of an indicator of innate immunity, immunity early on in life. And then we have a post-weaning fecal egg count EBV that's more of an indicator of adaptive immunity. So as those animals get older and they're exposed to parasites multiple times, is their immune system able to learn and respond, recognize that parasite infection and fight it off? And so we can collect both of those measurements. We can submit data for both of those measurements and utilize both of those for selection. And some flocks do both. Some flocks do one and not the other. They are genetically related. If animals are more parasite resistant at weaning, they do tend to be a little more parasite resistant post weaning, and vice versa. So, but for the most accurate EBVs, it is encouraged to collect data for both of those time points. And some of the cool work that Dr. Bowdridge is doing there at WVU, and you all have heard about it in some of the other webinars. And if this is your first webinar, I encourage you to go back to some of the recordings and check out some of the work that Dr. Bowdridge is doing related to the fecal egg count EBVs and its potential association with immunity to other diseases. And can we use this as a tool to improve immunological fitness and resistance to multiple different pathogens? So what does that example look like? Similar example that I used with weaning weight, comparing a ram in the 90th percentile to one at the 50th percentile. That more elite, that more parasite resistant ram at negative 79% for their weaning fecal egg count EBV, compared to that individual at the bottom at negative 39% or breed average. Again, they're going to pass on half of their genetic merit to their offspring. So the weaning fecal egg count expected progeny difference for the ram at the top would be negative 39.5%. For the ram at the bottom, it'd be negative 19.5%. And so if we were to compare the fecal egg counts of the offspring between these two rams bred to the same group of ewes, we would expect the fecal egg count difference between these lambs to be about 20%. And again, it's expressed as a percent change. And so percent increase, percent decrease. And so there's significant opportunity to lower fecal egg counts. And just 3 or 4 generations of breeding to elite low fecal egg count EBV rams, we can certainly see a reduction in fecal egg count and improve parasite resistance within our flock. Number of lambs born. So we get into our prolificacy traits. A number of lamb born is an indicator of prolificacy. Litter size, represented reported as the number of lambs born per ewe lambing. It is sometimes reported as a percentage. And so if you look on the searchable database, I think in there it's reported as a decimal, as a number of lambs born per ewe lambing. If you print out your individual listing there that you get back from sheep genetics, it's listed there as a percentage. I tend to think of it as a percentage, but you can think about it either way, whichever way your mind works. It is a trait that's expressed in our females, but certainly the trait in that EBV is available in our rams. In our males, and we can use that trait as a predictor of how well their daughters are going to perform. Number of lambs weaned combines that prolificacy with lamb survival. And so it's combining both things together. Really, the number of lambs weaned is a more powerful metric, right? Because they can have 5 or 6 lambs, but if only one makes it to weaning, that doesn't do us a whole lot of good. I'd much prefer them to have 2 and raise 2. And so a number of lambs weaned typically receives a lot more emphasis, the number of lambs born. It combines that prolificacy and survival, as I mentioned, is reported as a number of lambs weaned relative to per ewe lambing. It can also be reported as a percentage, and this also is expressed in our females. So what does this look like in reality? Number of lambs weaned, EBV. So the ram on the top would be at 21. I showed them here as percentages. Again, you can think about them either way. 21% versus 12% with comparing a ram in the 90th percentile to one at the 50th percentile. They're going to pass on half of that to their daughters. And so it'd be 10.5% and the daughters of the ram on the top, 6% and daughters of the ram on the bottom. So if we compared, the number of the litter size at weaning, number of lambs weaned per ewe lambing in those daughters, we would expect additional lambs weaned of 4.5% or 4.5 more lambs per 100 lambing events, or 0.045 lambs per ewe. There's a couple different ways you can think about it there. Hopefully that's not too confusing. But you're going to observe, you're going to see larger litter sizes being weaned, surviving to weaning, and those daughters of the ram at the top. We think about that in terms of its economic value, economic relevance. And again, this price is going to vary greatly. I just threw a number, $150 per weaned lamb. Again, that's going to vary based on how heavy they are at weaning and when you're selling them, where you're selling them, what time of year, all that. But I just threw out $150 for a weaned lamb. Relative to these metrics would be equivalent value of about $6.75 per litter. And so that would be every daughter, every year she lambs, producing a litter that's worth $6.75 more out of, in daughters out of the ram on the top versus the daughters of the ram that are listed there at the bottom. So certainly an economic value, economic incentive there, revenue incentive there in producing and generating daughters that are more prolific and keep those lambs alive to the weaning time point. The maternal hair index, this is often just listed as the hair index, and that one can be a little bit confusing, especially to new folks. The hair index is not a predictor of shedding ability. It's just the way we describe or label the maternal index in our Katahdin sheep. It is the maternal hair index. And it combines weaning weight, maternal weaning weight, number of lambs born, and number of lambs weaned into one metric, one value that serves as an indicator of weight of lamb weaned per ewe lambing. And so it's going to weight these different traits, these different EBVs accordingly to help us predict differences in litter weaning weight. It also is reported in kilograms, and it's expressed in the females, but we certainly have this index available in our males as well. And so what does this look like? Right now, rams in the 90th percentile are going to have a maternal hair index of 104.5 compared to rams at breed average 50th percentile of 102.9. Again, they're only going to pass on half of that to their offspring. So we divide it by 2, start comparing differences in litter weights between the daughters of these 2 rams. And we would expect differences of about 0.8 kilograms or 1.76 pounds per litter. And that's every time they lamb. So, hopefully our replacement females, those daughters, would have multiple lambing seasons in their lifetime. And so we could certainly extrapolate that out over lifetime productivity. And so if we take that, compare that to market value, it could be $3.50, upwards $6 or more in value per litter. And that's at every lambing event. So how does that math look like if you want to extrapolate that out? Let's just say you're trying to decide which ram to use. And regardless, they're going to be bred to the same group of ewes over 3 years. You're going to retain over those 3 years, you're going to retain 25 daughters. Those daughters are going to stay in the flock for an average of 4 lambings. So that would be 100 total lambing events, right? 25 daughters times 4 lambing events, 100 total lambing events. And this is kind of conservative, right? Hopefully our replacement females are staying in the flock for more than just 4 lambing events. Over 3 years, we could probably retain more than just 25 daughters out of an individual ram. but kind of depends on the flock, obviously, and what your goals are. I looked up, 50-pound lambs last week. We're selling for 282 at St. Angelo. And so, what value might the ram on the top offer compared to the ram on the bottom? So again, similar math to what we just showed. The difference here in expected litter weight would be 1.76 pounds multiplied by the value, the market value of those lambs at 50 pounds would be $2.82. That equals about just shy of $5 in value, additional value per litter. That's going to be, that's going to be there across 100 total lambing events. And so in this example, in 100 total lambing events, 25 daughters over each daughter is going to have 4 lambing events. There'd be an economic, an incentive, revenue incentive of just shy of $500 of additional revenue generated by daughters of that ram on top versus the ram on the bottom. And so there's certainly economic components to this, right? I'm not here to say maximize everything, but we need to think about our individual flocks and what our goals are and optimize our EBVs for our scenario. And so in summary, like I said, bigger isn't always better. We need to think about our individual flocks. Your goals are going to be different than my goals. But we need to determine what those goals are. We need to assess our current level of production. What are we doing good at right now versus where are opportunities for improvement. And then based on our established goals, current levels of production, we can then prioritize traits for selection. Remember, if we select for everything at the same time, you're going to make very little progress in any single trait. Rather, we want to identify maybe 2 or 3 traits to put a lot of selection pressure on at a single time. Once those traits reach our goals, then we can move on to other traits. And so once we have traits that are prioritized, we can then identify rams that meet and fit those priorities. And the traits that fit the priorities for my operation are likely very different than the rams that fit the priorities for your operation. And that's perfectly fine. And we just need to understand, though, that if without establishing goals, without knowing where we're at today and assessing current levels of production, it's really hard to tell which ram is best, which ram is the right ram for your operation at this time. And what's, the ram that's going to move your flock forward and get you closer to your goals long term. Rams that are more extreme for a given trait will accelerate progress for that trait. But you need to know when enough is enough. A trait, fecal egg counts are ones that we can probably push pretty hard, right, towards the extreme side. Lower fecal egg counts are almost always better, right? Lower fecal egg counts, more parasite resistant, ewes that are more fit and adapted to a forage-based environment. That's going to be a positive thing. But a trait like number of lambs born or number of lambs weaned, that might be a trait we want to kind of optimize, right? We want to find that happy medium. If we maximize a trait like that, we may have way more triplets than what we want. And so if I realize, maybe I'm sitting at 125% lamb drop right now, that needs to improve. So I'm going to put a ton of selection pressure on that. I'm going to find a ram that's in the top, the 90, 95th percentile, that's really extreme for number of lambs born or weaned. I'm going to put a ton of selection pressure on that. I'm going to make daughters that have improved in genetic merit very quickly. But then once I reach those goals and reach that lambing percentage I'm looking for, I'm going to dial that back. And I'm going to maybe find rams that are more moderate and optimized for that trait to maintain that level of performance that's optimized for my production system. So just as an example, in our NC State flock, our ewes, we don't put a ton of selection pressure on prolificacy. Our ewes that lambed here at our research station in Reidsville, North Carolina, their number of lambs born, number of lambs weaned, EBV, their average EBV sits right at the 60th percentile. So they're top 40% of the breed, slightly above breed average. Certainly not trait leaders. They're just slightly better than average, right? Our ewes this year had a 225% lamb drop and weaned right at 200%. We had 6% of those lambs are born were bottle lambs, 5% death loss. That is as much prolificacy as I want. It's probably actually a little bit too much. I would love to have a 200, 205% drop and wean 190 to 200. And so we're sitting at our genetics are at the 60th percentile in our flock for that trait, and we're getting more than enough prolificacy for our production system. That's for our production system, and that's going to vary to your production system. Remember, we're not, these EBVs don't predict an exact level of performance. That exact level, that same EBV may not generate the same level of prolificacy in your flock, or it might generate more prolificacy in your flock. It just depends, and that's where record keeping and data become really important. So we need a breed sheep that fit our environmental constraints, meet our market demands, and balancing those and making sure we have sheep that are sustainable. You can't sell a dead sheep, and so you need to find ones that thrive in your environment, perform in your environment, but also meet the demands of your customer base. And so with that, I probably talked way over time here, but I will turn the floor over to Etienne and let him share some about his tool that he has available, and a resource that I know a lot of you have utilized and is a great resource for our industry and helping make selection decisions and mate use. So I will unshare here. I don't know if we just want to take questions at the end.
Yeah, I think we're going to go
best.
ahead and take questions at the end. We're going to go ahead and have Etienne share his screen, go over the sheep tools. We'll say the Tiger Woods Bob Daly meme may be one of my favorites. So glad that one made it into the presentation.
Okay, Cam, can you see my screen?
Yep, we can see your screen and we can hear you. So we will listen.
Okay, let me just drag this a little bit out of the way. So we're a medium-sized flock. We had about 320 lambs this year. And from the start, we realized that we need to, when we look at our lambs, we need to adjust for birth weight, birth type, rear type, dam age, the cider that was used. We knew that ewe lambs had typically had a lower fecal egg count than ram lambs, so we need to adjust for that. And there's so many other things that we realize that we need to adjust for, and that's correlated, as Andrew described. So it didn't take us long to get to the point where we knew that we needed EBVs in our flock to help with our selection. When you look at 150 ram lambs to try and decide which ones you want to test out further, it's difficult to get beyond the point where the numbers just all blur together as you go through one page to the other page of your individual listing and think, this one looks good, and then 2 pages down, oh, this one looks good. And you just start to lose track of things. So we did a lot of work where we would work in Excel and create a list that we burn down to our short list so that we can go and evaluate phenotype, and from there further decide what we want to do. And that all evolved into the compare tool that I'm going to show tonight, and really just scratching the surface here. So what I've got loaded here are all the rams from the 2024 EAPK sale. And I will provide links at the end how you can access it. I plan to create the same kind of list for the 2025 rams, just as an alternate way to evaluate, because you get the same kind of thing as you go through the listing on the auction site. It's just ram after ram after ram. Last year there was 39 rams, so you can kind of get lost in all of the numbers or all of the animals, where you really at some point just want to look at the numbers and work with it. So I'm here on the main tab, showing EBVs. All the animals are listed. You can scroll down using the right-hand side, or if you've got a trackpad, you can scroll over the numbers. And it's just listing all the animals all the rams that were in the sale. So you can click on the headers to sort by different EBVs for all these animals. And the cells are colored according to the percentile and the scale is shown here at the top. So that's kind of just the basic lay of the land. You can change which EBVs are displayed by clicking on the cogs and clicking on EBVs. So let's say you were interested in PEMD, and let's say you were not interested in number of lambs born, you can unselect it and click OK, and your display will be updated. I'm going to switch back to the default, put back number of lambs born. So, okay, so you can now add more information depending on what your interests are. So you can enable other data to be displayed. So the screen gets kind of wide. Again, you can either use the bottom scroll bar, or you can use your trackpad to scroll left and right. When you enable other information, you can see the date of birth, the sex, birth type, rear type, sire, dam, and all of this information is available on the NSIP searchable database, but this brings it all together for a subset of animals in a list form. So we've got the age of the dam when this ram was born, the age of the ram itself, how many progeny and how many flocks, and what percentage of pedigree in NSIP is known. And the pedigree known in NSIP is calculated based on what percentage of the 30 closest relatives are known in NSIP. So you can hide the other information by clicking it again. And it really depends on what you're interested. Again, when you display it, you can click on the fields to sort it. We can look at progeny, for instance, where we've got the one at the top here with 126 tested progeny. And we use that kind of information as part of our selection. You can also enable genetics, which shows you which of these animals are genotyped. So in general, you would expect a genotyped animal to have more accurate EBVs or more representative EBVs. You can disable it. Again, you can also sort by it if you want to. So the next piece is percentile. So you can, when you look at just the EBVs, you can look at these top two animals with the two best PFECs, and it's like, well, are these differences really significant or not? You can already see by the color that they are in the same percentile band. You can click on percentile, and what that would do is display the percentile for you for the EBVs. So if you prefer to just work in terms of percentiles, you can disable the display of EBVs, and now you just work on percentile. And the percentile scale goes from 0 to 100, with 0 being least and 100 being most. And it gives you this context, and it's not what's in the sale. It is for the animals that NSIP used to generate the percentile rankings. This is where this ram ranks percentile wise. And I specifically said more or less because it's not necessarily good or bad. In our flock, we have about a 220% lambing rate for our adults, and our number of lambs born for our adults on average is at the 20th percentile. So it's a good lambing rate. We don't need more for our system. We've got lower number of lambs born, but it's good for us. So whether it's good or bad will depend on your system and where you are, what you want to do, and how does your animals currently perform in your system. I'm going to enable EBVs again. disable the display of percentile. So next, accuracies. Accuracies is a scale from 0 to 100, and the accuracy value gives you an indication of how well the animal is tested. Or you can look at it another way and say it is how likely the EBV is expected to change or how much it's expected to change, with 0 being not tested at all, or you can expect quite a bit of change or not. And where 100 is, it's perfectly tested. There's no animals with 100 accuracy. You get some animals some rams that would get up to like 98, 99 or so, depending on the trait, but EBVs are going to change. The accuracy just gives you an indication of what level of risk you are taking or how far this can change. Now, it doesn't always go down. So you can say, here's an animal with an EBV that you really like. It's got low accuracy. There's huge potential on the upside and the downside. Or you can say you need more of a sure thing. So you're going to be focusing more on higher accuracy. The EBV is perhaps not as high or as high a percentile as you would want, but you want something that you don't have to mess around with testing. You want a little bit more certainty, and you are willing to give up on actual genetic merit. Um, you know, the the accuracy calculation is based on the animal's own testing, testing of the ancestors, testing of their offspring, whether they are genotyped, as well as correlated traits that have been tested. So, for instance, you can have an increase in number of lambs born accuracy by actually testing scrotal circumference on ram lambs. So all of those things contribute to what goes into the accuracy. For what you are displaying, you can click on this little Excel icon, and what it would do is export your current view to an Excel file with whatever data you are displaying right now. So if you prefer to work with it further in Excel, you can do that. So let's do some selection. You need to decide what traits you need. I can't tell you what traits you need, and the system can't tell you what traits you need. So if you're already in NSIP, you should have a good sense of where your flock stands, and you can use that as a baseline from where to make your decisions. On the other hand, if you've used an NSIP RAM before, but you are not in NSIP, you can look at that and say, what do I need more of and what do I need less of? So you can look at the current EBVs of that RAM and say, I need a little bit more parasite resistance. I need a little bit less prolificity. I need a little bit more milk. And you can use that as a reference point from where you can adjust what you're looking for in the purchase of your next NSIP RAM. If you've never purchased an NSIP RAM before, or you're not in NSIP, then you have to assess for yourself, where do you feel you are? Where do you feel your animals are? And when you go and purchase, what do you want to focus on? And you will be able to, over time, triangulate what works for you and what doesn't. And that's not any different from when you purchase an animal without EBVs, where you have to you have to decide based on what the breeder tells you. In this case, it's based on what has been measured, and the percentile values are really going to be useful for you to make your decisions. Now, if you're in NSIP, you can go to the compare tool with your flock ID as shown in the URL. This is our flock. Go to animals. By default, it's going to do it for the most recent year of lambing. So I'll click and add all our ewes in this list and say add. Here's all the ewes. We'll click OK. Now I've loaded all the ewes that we lambed this year. You can go to ranking. You can decide which EBVs you want to look at. So let's go to PFEC. And you will get a whisker plot of all your ewes. So I can put my mouse over this and see the average for our ewes. PFEC is -21. The median is slightly off with -34. We've got a few outliers here that you can put your mouse over and see who they are. So this gives you a easy overview of where you are with certain traits. And you can play around on the ranking with switching this to percentile. So in this case, the 100th percentile is at the top. There's a few here at the bottom, 0th percentile. Then, or you can switch accuracy if you find that interesting for yourself. A little bit more difficult to interpret. For instance, I will switch to weaning weight. And you can break that out by their age, for instance. So we've got the age of the ewe at the bottom, and we have, for each of those age groups, you can see what the mean and median and what the different quartiles for them are. So if you're in NSIP, you can work for yourself to see where your ewes are, if it's about improving your ewes, or you can look at where your lambs are if it's about improving your lambs. So let's do some selection based on what I've gone through now. So let's say I want to focus on PFEC, but I don't want to go backwards in maternal weaning weight and weaning weight. So what I'm going to do is I'm going to click on the filter here and say, I want my maternal weaning weight percentile to be greater than or equal to the 50th percentile. I'm going to click on the plus to add an additional filter. And next, I'm going to go and choose my weaning weight. Also to be greater than or equal to the 50th percentile. I'm going to click OK. And now it shows that it is displaying 18 of the 39 rams that's there. And it's filtered by those conditions. You can go back to the filter by clicking on the icon, or you can temporarily disable it to display it that way. So next, I'm going to sort by PFEC. So what's being displayed now is my weaning weight is the 50th percentile or better. My maternal weaning weight is the 50th percentile or better. And I've sorted by PFEC. So you can see you've got a selection of animals here. And you can see, you can decide, well, okay, I like the top 5. So I'll click the first one, hold in the shift key and click the 5th one. Right click, set, blue. Misclicked. So these guys are now flagged as blue. I can go and say, well, I want to, just for interest's sake, sort maternal weaning weight. And I'll click, hold in shift, right click, set, green. So you can see here that out of your top 5, you have 2 that match both your PFEC as well as that's in the top 5 for maternal weaning weight. So that's a simple example of how you can work through that. If we try and make it a little bit more complex, what I'll do is I'll open this up and delete my filter, click OK. I'll right click here and say set everything to none. So we're back in our original state. If you want, I'll sort by the ID. And let's go to something a little bit more interesting where we can look at making more trade-offs. So, and this hypothetical, although it's based on reality, we prefer to use or to buy rams out of dams that are 3-year-old or older. And even when we, some of the rams that we pick out of our ram lamb crop, we prefer to have it out of older ewes because they've been here and they've delivered a few lambing seasons, as well as, the ewe itself is better tested. So what we'll do is we'll sort by dam age and say we'll pick the first one and we will scroll down up to line 19. We'll select them all and say right click, we'll set them to blue. So these are all the ewes that, or all the rams that were born out of dams that were 3-year-old or older. Next, it's always nice to have rams that actually have progeny that are in NSIP. So what we'll do is I sort it by progeny. I'll pick the first one. I'll go down to this one here, and I will right click and mark that as green. So then we say, well, we are focusing on maternal weaning weight. So what I'll do is I'll disable others and I'll go to sort by maternal weaning weight. This is, we want to sort it descending. So out of this sale, I want to look at the top, let's say 20. But as I've marked them, I noticed that, well, these guys here are pretty much in the same percentile band. So what I'll do is rather than just the top 20, I will select the top 24 and I will mark that as yellow. So I'll right click, I'll set yellow. Then if in your case you were interested in number of lambs born because you want to increase your lambing rate, we'll do the same kind of thing where we say we sort it descending. I'll pick the first one, go down to 20. Again, looking at this, well, all these are still the 70th percentile, so I'll just go down to selecting the first 22. I'll right click, set, and I'll make that orange. We'll take another step and say PFEC. I'll sort it and I'll pick the first one, and I'm going to go down to the top 20 here, and I'll right click and I'll set that to red. So I'll click here, sorting on the flags. Now it's time to make some trade-offs. You know, we've got quite a few that are marked. There are some that fulfill just one criteria. There's others that fulfill 4 out of the 5 criteria that's there. And you can start making your trade-offs as far as which of these are less or more important to you. You know, when looking at this, you'll notice, like, for instance, here's one where the PFEC is 0. Just for interest's sake, I'll display the accuracies, and you will notice that there's actually an accuracy of 0. So that's not tested at all. So I'll probably stay away from that. On the other hand, you look at this and say, here's one ours with an accuracy of 86. Great. And we can now say, well, let's go to the filter and select the filter where flagging, where there's saying no flags equals to no. So that means that at least something is flagged. And now we have our list of just animals that at least have some flagging. And from here, we can go and we can sort, we can resort, and we can export to Excel and, you know, work further on making our trade-offs. So the link that I'll provide later on for the symposium sale will have animals preloaded, but you can click on animals, you can enter your own IDs or paste them in if they are not part of your flock, and add them to the comparison. So if you want to put in your own rams from this year or that you're currently using, you can add it in from there. Let me think. I don't want to take up too much of your time. So there's a few important links, I think, or useful links. So if you go into the compare tool with if you're in NSIP, you can use this URL, compare, and then your flock ID. If you're not in NSIP and you want to just play around with data, you can go in with just a dummy Katahdin flock, 640 000. You can look at last year's EAPK RAMs by putting in this URL with the EAPK 2024/RAMs. You can do the same for U's, or you can combine the U's and the RAMs. There's the searchable database link, the NSIP percentile. Then EAPK has some good fact sheets and concepts and a glossary of terms. Here's a link to a percentile blog that I wrote, doing a deep dive into percentiles. And then you can also go to the wiki page with some tutorials in Sheep Tools that focuses a bit more on the planning piece that you can go to at info.sheeptools.com. Once the consignments for the 2025 sale starts to be created, I'll add a link for the EAPK 2025 that will contain the animals for this year's sale. If you have any questions or so, you can contact me at this email address. So I really just scratched the surface, but There's a lot more you can do in the compare tool. Don't be afraid to play around with it. The other items on here, the trade-offs, is everything's a trade-off. So let's say you want to trade off index against PFEC. You can select those and you can see at the bottom is the index, at the left is PFEC. Everything's a trade-off. You can hold your mouse over this, or you can drag a rectangle. Let's say the animals in the bottom quadrant is of interest to you. You can select it, and then it would show you which of those animals fall in this rectangle. You can double click to reset it. So you can play around with x-axis, y-axis, and then coloring. For instance, you can say color it by dam age, and you can get that information, or color it by, let's go, maternal weaning weight. Then you can look here and say, okay, hold your mouse over. The index is 100 point. Oh, sorry, I lied about what to select, but you can see the different traits you have there. I should have said, in this case, we want the good parasite resistance with a good index. So you really wanted the right bottom to look at. The ranking I showed just briefly. You can also look at the overview. The markings we made carried over. You can view the radar chart by moving your mouse over. It shows the accuracy as well as the percentile. And then, we enjoy and we value depth of pedigree. So you can click on show hierarchy, which shows the animal. You can click the plus and expand it further to see the sire and the dam as well as their EBVs. And you can go quite a few levels down to look at the EBVs and get an idea where it comes from. Does it come from a solid pedigree, or was it that the dam was good, the sire was not, and this lamb might have been lucky? And again, it's all about trade-offs and what you value more or less. The relatedness is a little bit more complex, and I'll skip that for now. So Cam, without diving too deep, I think that's why I should stop then.
Yeah, that was great. I know a lot of positive comments here in the chat, and we were joking around there at the beginning before we started. Just the number of times I've heard, like, I don't know what I would do if I couldn't plug data in and plug dams in, sires in, and make breeding decisions. And certainly owe a lot of credit to the tool, especially the planning side. I think it has a lot of opportunity on the ram selection side as well. You mentioned there were 39 rams that sold last year at the EAPK sale, and it does get tiring when you're scrolling from lot number 2 to lot number 30 and trying to keep everything straight. So with that, if there are any questions, we are ready to take them, whether it's with Andrew or with Etienne. And again, can't say thank you enough to both of those gentlemen for hopping in tonight and providing information.
I did
I know
see
there was a
one-
question. Yeah, the question in the chat.
Yeah, there's a question about when are we taking weaning fecal egg counts? We do it the day of weaning, maybe the day before if just timing restraints. Some of our work, actually my graduate school work, there at the Southwest Virginia Research Station, we collected weekly fecals starting at the first vaccination. They're about 45 days of age, and then did that all the way through weaning, and then continued on for 5-6 weeks post weaning. And it was really interesting. The fecal egg counts tracked by sire group and sire fecal egg count EBV really well pre-weaning. And then weaning happened, and they all kind of went crazy. And then everything settled down, and the fecal egg counts of the lambs aligned very closely, and as expected, as predicted, based on fecal egg count EBV, beginning about 4 weeks post weaning. And so as a result of that, we've really stopped any fecal collections within 4 weeks of weaning. And I encourage producers to collect fecals up to the day of weaning, and then hold off and wait at least 30 days before collecting another fecal. I just feel for accurate fecal egg counts contributing to the prediction of fecal egg count EBVs, I'd hate for that weaning stress to do something there that maybe makes an animal look bad when they're actually pretty good, or look pretty good when they're actually pretty bad. We just don't know what's going on in that time period. And if we just refrain from that time period, we probably have a more accurate depiction of what those lambs really are from a genetic standpoint, in terms of resistance or susceptibility.
Yeah, good answer to that question. Was on the phone earlier with a producer that had been losing some lambs to some acute hemochromatosis there after weaning. So definitely a concern. I should mention too, I don't want to forget, we talked about that EAPK symposium sale and sorting through rams. EAPK is planning to have another symposium and sale, really good educational event, and a lot of quality speakers in Elizabethtown, Kentucky, July 11th and 12th. And one of the additions to this year's program is actually having some educational content on Friday, starting at noon, I believe. So if you want to join us in Kentucky, would be happy to have you and learn and buy some sheep. Just hop on the website and register there. But any other questions this evening?
Andrew, what age did you wean, at study at Southwest Station? What age did you wean that year?
They were typically 70, 80 days of age. Average birth date, third or fourth week of March. And then wean, the first week of June, first or second week of June.
The closer to 60 you'd wean, probably the bigger the stress would be. 60 days, the bigger the stress, and
right. Yeah, definitely. Those sheep were raised, developed on grass with little supplementation, and kind of the system that's been used at the station for a while, and kind of timing wise. And I guess they're not quite 90 days. I guess the oldest ones would be just probably getting to 90 days, but the majority would be between 60 and 90.
Any other questions this evening?
Etienne, is there a place to find those links on your platform?
No, I can I can paste them into the chat session quickly.
Okay.
Keep it going here for at least a couple more minutes for you to copy and paste.
I'm quick.
Yeah, no, you're good. You're good. And like we said at the start, this has been recorded. We will get it uploaded onto YouTube. You can find that link on the website. And if you're like me, you're gonna have to go back and watch it maybe a second, third time, and revisit it in 6 months when you need to do it again. So look forward to having that recording on there and access to it for producers.
Cam, one thing I think that would be good is, I know EAPK didn't do it last year, but if you can request a data refresh of the searchable database after the first of the month.
The
they-
July 1.
Yeah,
run.
so
Yeah.
that you don't have producers that submitted new data for the July 1st data, and then the searchable database as well as my tool is out of sync, because you never know if it was a typo or if there was new data that came in.
Yeah. Yeah, and I think that's a great point. I mean, we have Andrew in here. I believe I saw Lynn Farmeyer in here as well. It's my understanding that searchable database is updating the fifth after the mid-month, that 15th of the month data run. I believe a couple years ago, EAPK had gotten a hold of Rusty at the time and requested an update of that July 1 run, because it is, to your point, Etienne, if we get those samples submitted, fecal samples or post-weaning weight samples submitted on ram lambs, ewe lambs from the spring, submit those late June for that late June run. That it can be very different than what's actually displayed on the searchable database. And that's where your tool is pulling information from. And yeah, we can certainly pass that on to David Scales and see what we can do to get that updated. Anything else this evening? If not, appreciate everybody for hopping in here, and really appreciate Dr. Weaver and Etienne for providing information in your time. Look forward to seeing you again next month. We're excited to talk about marketing with Zach Minders there from Iowa. And if we don't see you then, hopefully we see you in Elizabethtown, Kentucky. So have a great evening, and we will see you next time.
Thanks, Etienne. Thanks, Andrew.